going to go through all of the hand functions, some you know and some you don't know. We learned this year, instead of the whole term on this function, the quadratic, y equals a times x minus h all squared plus k. Does that look familiar? Oh, come on. It doesn't look familiar? Are you kidding me? Yeah, that's the parabola, quadratic. And the a does something to the graph. The h does something to the graph. The k does something to the graph. Oh dear. Okay, last year you learned a function besides the linear function. You remember which function we worked on last year? So yeah, y equals mx plus b, that's a linear function, but there was another function you learned about last year as well. Yeah. That was this year. Next to the word exponential. It was like this. Now it was like this. Exponential growth and exponential decay. Everybody know? Oh heavens, kids are asleep. Okay, there can still be a multiplier, a, on exponentials. Exponential needs a base, raised to an exponent, and then if there's any like plus outside, that would do the same type of shift as it would do with quadratic, which will do another shifts again in a minute. Now it used to be, in segment 2, that we would teach you like 6 or 7 different functions. But this year, I think we're only running 2. I will figure that out in a minute. And we've moved the other functions into next year. You have a question? No, it is a base. A base. And the h is still up in the exponent. Okay, so this is how an exponential function looks. We can also have a cubic function, which is very similar to a quadratic except for everything is cubed. We'll learn about that function next year. There's also a square root function. So a square root function, what is it going to have in the equation? A square root. There's still a is always in front. Square root x minus h plus k. And k, notice, is after the square root ends. Next year, also learn a cube root function. We talked about cube roots. If we gotta remember, if we have an index of 3, what that is as an exponent. So I'm negative 3. And the index in the denominator, it's negative. There's 1, remember how the index becomes the denominator of your exponential exponent? And what am I missing? Oh, let's put in the absolute value on what we're doing today. A times that's the value of x minus h plus k. We go on to the trig functions that we'll be learning next year as well, also have the same properties. But in the front, look at all of these different types of functions. With this a always multiplying. The a is always multiplying, right? A does 3 possible different things to the graph. Let's see, I remember it's minus. I'm tired today, so it remembers what a does to the graph. We've done quadratics, so an a out here in the quadratic. What does it do to the graph? Yeah, it's either concave up or concave down. What is it going to be concave down? Okay, so I'm correct you, but a is less than 0. But we don't have an instance when our multiplier, a, the absolute value of which is greater than 1. Oh, let's put here, a less than 0 is a vertical it upside down. Anything is very similar to a slope. So you can write the run if you have a greater than 0, like 5 over 2. You would be going up 5, out 2. Up 5, out 2. Are you going up more or out more? Up 5, out 2. Up 5, out 2. Up 5, you're going up more. If you pull something up, what happens to it? It stretches. The arms come in and it gets skinnier, right? So when our multiplier is greater than 1, it's a vertical, let's show that, stretch. Okay, our other option is when the absolute value of A is between 0 and 1. Like a fraction, or it can even be a decimal. A fraction things you're thinking about. Like a fraction 1/3 is between 0 and 1. If I go up 1, out 3, up 1, out 3, but like up more or out more? Up 1, out 3. Like out more. So the graph is skinnier when I went out more. It's getting wider. So it's not a vertical stretch, it's a vertical compression, because when you push them down, so we lean on the sides. I hope you're actually listening. It's just something that's up in space. This should be something you already know. I've already gone over it many times. Vertical compression. Okay. No matter what function, what type of function we have, if there's a multiplier in front of the function, it will do the same thing to the graph. Okay? We already know what the h does to the quadratic function. Guess what? It's going to do the same thing, even if it's on a cubic. H does something, k does something. Again, remember what h does to the graph. Cubes. It will start with an h. That's right. Horizontal shift. I thought I changed colors. Horizontal shift. It's on this side. That is k to the graph. Because that's what I moment shift. Vertical. Vertical shift. Oh my heavens, I'm going to do jumping jacks. Vertical shift, I have the same. Okay, the two rows back there. What's the same? From here and here. Yeah? Good, vertical shift. We have to pay something less than here for our little thing. Two rows back there, what's the same? And it's really good. You know, she's put in there, but she's not in two rows. Right there. All right, heavens. Wow, it's been a long time. Okay, I'll have to jump into the second now. Opposite thing, back to this. Does that sound familiar? Opposite thing with boards. Pulling them up, and we could see the vertex by just looking at the equation. Oh dear. Opposite same. Okay, I guess a good way to start with finding the vertex of quadratics. Before we do absolute values, because we forgot everything. Okay, I'm going to rewrite this on the board so you can see it. Doesn't really matter which function I put. Like I mentioned, the name of the function tells you where the grouping for the function is. Look at the h. It's inside the quadratic, right? This one called exponential. Where's the h? In the exponent. This one called cubic. Where's the h? In the thing being cubed. This one called square root. Where's Where's the h? In the square root. There's one called cube root. Where's the h? There's the cube root. There's one called absolute value. Where's the h? And the absolute value. So inside the function of the actual name of the function, there's anything being added or subtracted, that's a horizontal shift. Look at what the k is. The k is after the squared. The k is after the exponent. The k is after the cube. The k is after the square root, after the cube root, after the absolute value. And there's something on the tail end outside the function being added or subtracted, that's a vertical shift. Okay? So, let me do it right here. Horizontal shift, vertical shift, opposite, same. Really quick. A less than 0 is a vertical flip. Absolute value greater than 1 is a vertical stretch. A being between 0 and 1 is a vertical compression. Okay. We're going to practice identify the vertex, and we're going to do a rough sketch, or a rough graph. Nothing is perfectly precise, but a basic idea. Example 1, y equals x minus 4 squared plus 2. Y equals x minus 4 squared plus 2. To find the vertex, you should be able to see it. This is called vertex 1 because you can see the vertex. I can see something in the function, I can see something after the function. So we say opposite, same. So anytime you're able to discuss what the vertex of this function is, they want an opposite, same. Here's your neighbor, look at these two. They do it correctly, I'm going to you. Opposite, same. What's the vertex? Opposite, same. What's the vertex? Yeah, there's one number. A point has two numbers in common between them. Opposite, same. Here, what's the opposite? Same. 4, 2, exactly. Vertex is 4, 2. Which means we move horizontal, opposite. What's opposite of the negative side horizontally? So right, 4. This 2 is the vertical shift. It's same sign, so the vertex moves vertically, up or down, up, 2. So we take our vertex, which is normally the origin, and we go right, 1, 2, 3, 4, up, 1, 2. And that's the vertex. Look at the A. And see there's the multiplier in front of the parentheses. What's the multiplier in there in front of the parentheses? Okay. Besides your line, well better besides you want 2 answers. What number is in front of the parentheses? Quentin? The 1. If it's not there, the 1. Does counting by 1 do anything to them? Anything? No. So it's going to be our standard parabola, and it's positive, so goes up. Okay, example 2. Y equals negative x minus 3 squared plus 5. Y equals negative x minus 3 squared plus 5. Can you check me please? Actually talk to them this time. Think about opposite, same, and tell each other what the vertex is. And keep telling them back the same answer. Brandon, what do you get? You're drawing close, but that sounds like same thing to me. You need the opposite. It is a negative 3, so what's the opposite? Positive 3. So the vertex is positive 3, comma, 5. Opposite, same. Okay, so this one is a horizontal shift. You can tell me in 4 words what the minus 3 does to the graph. We're going to give me the first 2 words. Horizontal shift. Can you finish it? It's minus. We think opposite. Which way is that? Right or left? It's normally the negatives are on the left, so we have to think opposite. So right, how many? 3. Horizontal shift, right, 3. The 5, can you tell me in 4 words? So the 5 goes to the graph. Allison? So actually, go across, we up or down. Up or down. Good, up, 5. We have the same sign, the positives are up. So we take our vertex, which used to be at the origin, and we have to shift right. 1, 2, 3. Go up. 1, 2, 3, 4, 5. Okay. Finish the answer. What is the A? Finish the answer. What is A? The multiplier. The front of the parentheses are multiplied. Okay, 2 answers. Half me right, half me not. Thirdly, what number is that off from? I see positive 1 and I see negative 1. Is it a positive 1? It's a negative 1. Turn to your neighbor and tell them what the negative does to the graph, please. That doesn't sound like actually what's going to have you. Say what is the negative to the graph? What restriction? Horizontally or vertically? Vertically. So we have to put our parabola contour down. This is just a rough sketch, so just get the basic idea. Okay, one more before we do absolute value. Y equals negative 5 times x plus 2 squared minus 4. Y equals negative 5 is x plus 2 squared minus 4. Now we have that written down. Here's your A right, tell them what the vertex is of the graph. Then you need to neighbor. I didn't say that to anyone. The vertex, when we're opposite, same. Okay, we know what's the vertex. Good. Vertex, so it's opposite sign with a positive 2, so she said negative 2, and then same sign for the K, negative 4. Put the timing in 4 words for the plus 2 goes to the graph. Options are right or left or horizontal, and you have to do the opposite. So we have the positive numbers usually on the x-axis. There. So when you think opposite, so it's going to go left. How many? 2. Okay. 4 words. This is minus 4 due to the graph. Kevin. Vertical shift, down, 4, because it's the same. Vertically, your options are up and down. The negatives are down. Okay, put the calculator down. We don't need it right now. So, on our graph, we're going to go from the origin, we're going to go left, 1, 2, and down, 1, 2, 3, 4. Now, the vertex, which makes sense because it's at negative 2, negative 4. Okay? Here's the error. What is our A this time? Here's the error. What is our A this time? Now, you have to both answer this. Now we change the number. There you go. Okay, what is A? Let's see, Jake, what is A? Negative 5. Okay, this does two things to the graph. So we can even what two things does it do to the graph? And then did you tell the two things that the negative 5 multiplier does to the graph? Can you? So the cheat sheet over there on the board, can you look at it? Alright, exactly. What does the negative 5 do to the graph? 5, the absolute value of negative 5 is positive 5. Is that between 0 and 1? No, so it's actually greater than 1, right? So instead of compression, the vertical stretch. And what does the negative do to the graph? Flips it. So if we stretch it, should the graph get wider or should it get skinnier? Skinnier. And 5 is actually a pretty good stretch, so it's going to be pretty skinny. And goes down. Okay, now we're going to see what an absolute value function looks like and perform these same transformations on them. Okay, example 4. We're going to graph. This is called the parent function. Graph the parent function. The parent function is the most basic absolute value function with no extra details. So it's just y equals absolute value x. Okay, make sure you put long bars on the absolute value so you don't get confused and think it's 1x1. Okay, here's what we need to calculate. So if you have your calculator, open it up please. Everyone should have picked one up by now. Ooh, there's mine. Okay, open up your calculators. Come on. Come on. Okay, put mine right there. I can see everything. Okay. We need to go get the calculator, the function, y equals absolute value x. So what button do we have to push before we give the calculator the function? Y equals, your calculator needs to be open in order to do this. Please open it and turn it on. We're going to go with y equals to the top left. Everything else is inside there. Okay? Let's look at the buttons on the calculator. You see an absolute value sign. No, that's not there. So we have to go into a couple different buttons. And actually, I read the other day at faster way. I've always done it the long way. I think we went catalog. Let me see. Yeah. Okay, I always do it. I had to go to math, and then I had to go to number, and then it's sounds right there. There's a quicker way. Go back to. There we go. Okay, see on the number 0? It would say in blue. Catalog. And because the catalog's missing in alphabetical order and absolute value starts with an A, it's on the top. So we're going to go second catalog. You see atoms? Oops, my calculator disappeared. Source text. We went to y equals. Then we have to select, oops, steps, y equals. Then we have to select second, catalog, and abs. Okay, if you just push enter, it will select it. Now, why is when you used to have the parentheses? So you don't probably have the abs parentheses, so it's okay. You can just, after the parentheses, just push X, and then you just have to close your parentheses. So your calculator will look like this. Y equals abs, parentheses, X. Then you have to push the close the parentheses. Then it will close the absolute value. Okay, let's make sure everyone's in the same bracket window. Go to Zoom, which is up here in the middle. And Z standard gives you a negative 10 to positive 10 window. Which number is Z standard? 6. So all you have to do is hit number 6. And let's change the shape that absolute value function takes. What shape is that, Samantha? The U. The V. Are the arms curved or are they straight? Straight. We have two actually different linear arms. One has the negative slope, one has the positive slope. So our absolute value function looks like this. The vertex is at 0, 0, because if anything being added to the x, the absolute value is being added to the x. No, so the number is 0. Is there anything after the absolute value? No, so it's 0. So our vertex is 0, 0. Next to here, what is A? The multiplier in front. Over here, the multiplier in front can't be 0. Otherwise, everything will be 0. What's in front? The absolute value sign. So 1. That means that your slope. So A is a positive 1. It is our slope. Is it slope rise over run? So 1 over 1 is still 1. So from this point, I'm going to go rise 1, run 1. Rise 1, run 1. Rise 1, run 1. It should make a line because each of the arms are straight and they're linear. The definition of absolute value is distance from 0. So positive 4 is the same distance away as negative 4. Positive 3 is the same distance away as negative 3. So that's the value of negative 1 is still positive 1. That's the value of negative 2 is positive 2. That's the value of negative 3 is positive 3. So we kind of just reverse the slope. It just becomes a negative slope. One of the lines is positive, one of the lines is negative. If you need help drawing a straight line, you can use the edge of your calculator with. Did you see that save? That's pretty good. Edge of your calculator can help you adjust from that a little bit on. Okay. Let's go to the same problems we did with the quadratics. When you give you a function, you have to tell me what the vertex is, and you have the bags put down on the ground. You have a backpack on your lap or on your density on the ground right now, please. Yeah. We're going to the same problems but with absolute value. Y equals absolute value x minus 2 absolute value plus 3. X minus 2, close the absolute value, the absolute value is the next column on, plus 3. Okay, this is the same as quadratic, the opposite. Whatever's inside the absolute value, same whatever's outside the absolute value. Then you name and tell them what the vertex should be. Next on the screen, sting everyone. Opposite, same. Natasha, what's the vertex? Not Natasha. Totally wrong student. Haley, sorry. What's the vertex? So opposite, same. And 2, 3, perfect. So our vertex is 2, 3. You can tell me in 4 words what the -2 does to the graph. Same way the quadratic behaved. 4 words. I'm going to show you a red then. Well, Kyle. Horizontal shift, moving opposite. So right, 2. I need 4 words for what the +3 does to the graph. Allison? 3, because it's the same. Vertically up and down. So positives are up. Okay, so let's put that on. The vertex used to be at the origin, now it's on right 2. And up 1, 2, 3. Okay, next again here is what's the multiplier in front of the absolute value symbol? What's the multiplier in front of the absolute value symbol? And what is it? 1. The size of that not do anything. No, this is our slope. Our slope is 1 over 1. So we rise 1, run 1. So we rise 1, a few more lines here. Run 1, rise 1, run 1, rise 1, run 1. It gives us the positive arm of the absolute value. Did you draw that, Jason? Then I just reversed it. We're still need to rise, so we go left 1. Down the vertex again. I go up 1, left 1. Up 1, left 1. Up 1, left 1. And make sure your arms create a V. Quadratic should be curved at the U. Absolute value, U the value, starts with a V. Absolute value starts with a V. Okay, try another one. Example 6. Y equals -1/3 absolute value x, plus 4. Here's a challenge for you. Y equals -1/3 absolute value x, plus 4. And today I'm telling the vertex by using opposite, same. This one's a little bit challenging. Opposite, same. Change neighbor and tell the vertex. Opposite, same. The number, not x. What number is in your being added to the x? And the opposite, same. Opposite, same. Rita? Opposite, same. Nadia, what is the vertex here? 0. Ah, you got 0. What number is being added to the x? Is there a number? No, so 0. And then same, 0, 4. Vertex is 0, 4. So our horizontal shift this time is none. Horizontal shift is none. So we need 4 words for what the +4 does to the graph. I guess I'm going to have a better time, but thank you. Now you got it. 4 words that the +4 does to the graph. move them on. Go with, what is the plus 4 to do the graph? What type of shift is it? What type of shift is it if it's after the function? Okay, what type of shift? Vertical, shift, and then you take same. So what are the positives? Are they up or are they down? Up. How many? 4. What is the shift? Up. 4. Okay, so we need a graph. Move horizontally none, and go up 4. 1, 2, 3, 4, which is the point, 0, 4, that Nadia gave us. Okay, look at your partner next to you, because it's going to be in 3 hands. Hold up, what is our aid on multiplier or the slope? Look at your partner next to you, hold up the slope, please. Hold up the slope. This requires 3 hands, which is why you have to work with your neighbor. Put it together. What is our multiplier? Okay. You should have, Jason, what is A? Negative 1 over 3, so 1/3, and then someone should be doing the negative sign. So our slope is negative 1/3. Rise, negative 1, what's that mean? Rising a negative. You go down. Run, 3. So from your vertex, I'm going to have to give myself some more points. From your vertex, we go down 1, and run, 1, 2, 3. From the vertex, we go down 1 and run to the right, 1, 2, 3. Yeah, just mark that one a little bit. And that's our first arm. Now we need to do the opposite side. So we still go down, but we move left. Down 1. Left, 1, 2, 3. Down 1. Left, 1, 2, 3. Why is this B pointing downwards? Why is it opening down? Because A, our multiplier is negative. Okay. Everyone stand up. Stand up, stand up. If you go quietly, and I don't hear you until complaints, you might grab a drink and come back. Before you pull out the books.